So my name is Elena Bailey. I don't know if you guys have been to these workshops before, but we're celebrating our 20th year of workshops this year at WEFTEC. Yeah. And the truth is, nothing has changed. Our goals are exactly the same as they were 20 years ago. Discuss challenges and, solutions in the minds of the owners, and offer some things that are maybe sometimes innovative and sometimes even provocative, and to people who want to make a difference. And that's really why this workshop is so unique, and that's why we keep doing it for 20 years. And thank you, Dr. Dagger, for being part of it once again. So next, I would like to welcome Ellen Fraketic from Maryland Services. Ellen will represent the smaller size plants. She operates about 128 plants in Maryland. We have Jim McQuarrie, who is with Denver Metro, who treats all of the wastewater for Metro Denver. So that gives you the other side of the spectrum. And Jim focuses on strategy and innovation, so that will be very interesting to hear his point of view. And this year we have one of our own guys, David Williams. He is the Director of Digital Management, which is the IoT, trying to make a connection for Ovivo with customers. And then finally, we have Dr. Rushi Matkar. He's a technologies from Global Foundries, one of the leading semicon companies in the world. He used to manage the water and wastewater and ultra-pure water, but now he is in the fab, and he's in charge of the R&D as a program manager of the EUV, and it stands for Extreme Ultraviolet Platform for the 7 nanometer device. And I know that may not mean anything to us, but it's a lot of important stuff that you use on your phones, on everything you guys hold in your hands is made out of this kind of stuff. So when we asked Rushi to join us, I kind of said, well, you may represent the Mount Everest, and we may be the Mount Rushmore, but hopefully with all these speakers, and with the contribution of everybody, maybe we can rise to the occasion and be Mount Olympus, maybe, by the time we're done. Dr. Dagger, turn it over to you.
So I have to say I really am happy to have been involved in this over time. What we're going to address here is what you want us to address. So this is your program in that sense. So what we've done is consolidate this into 5 questions. The question they asked is, what's different? So, because quite frankly, the things that we're trying to do today, and I've been around for a good while, we've been trying to do those through my entire career. And in fact, some people have actually done them. But in the past, to do what today is a fairly small thing, to figure it out was a PhD thesis, or several PhD theses. Now, these are a bunch of hackers can go do things. And the costs are way down, and the availability of tools to take and harvest and utilize information, harvest and utilize data. It's just orders of magnitude. So I think, Elena was telling us all to turn these off and so forth. Think 10 or 15 years ago, did anybody here have a device that can do all of this? To me, that's the difference, is that things that used to be dreams or used to be extraordinarily expensive now are so easy to do. So the question then is, given there's all these things that we can do so easily and so simply, which ones make the difference? How do we do this? And how do we take advantage of the opportunities, realizing there will be challenges and so forth as we look to do these new things? That's my answer to what's different. So the objectives are not different, but our ability to realize it. First question, smart world is the future. That's not a question, that's a statement. It's a hypothesis, if you will. The Internet of Things promises to offer a revolutionary, fully connected, smart world as the relationships between process equipment in the plants, the environment, and people become more tightly intertwined? What opportunities? We'll get to the issues and problems later, but what opportunities does this offer for us?
There's a lot of data that we manage right now, and I think it's interesting that we're going to have a place to store all this data rather than, because I work for a state agency. We're an independent state agency, and we have, out of all of our facilities that we operate, we have like 80,000 pieces of data every year that we look at just in terms of things, violations, permit-related pieces of data, and to be able to see something instantaneously and look at the trending instantaneously online, from your phone, whatever, it's pretty exciting, but it's going to be for us and for some of our clients, because I don't just work for state clients. I have very small municipalities that we deal with. It's going to be a major shift as far as the technology is concerned. I think it's going to be different.
So I guess I could share a personal experience with regard to IoT, and that was Denver water, in a region where there's only 14 inches of rainwater a year and a population that's growing significantly. Incentivizes consumers to do things that save water. So I, not knowing what I was buying, I went for what was rebatable to get $150 back for the $250 I spent. And what I plugged in was a Rakio irrigation controller, and that was enlightening to me for what IoT was. And basically, I plugged in this controller, I set up my zones, and from there on, this controller looks at the time of the year. It considers the position of the sun based on time. It also scans the internet for weather data for my zip code, determines not only what has happened, but what's anticipated to happen. And as a consumer, I enjoyed about 20% savings in my water bills over the summer months. So that was my personal experience in terms of IoT, and what, if I could summarize it simply, is that I was able to leverage someone's ingenuity to do the work that I no longer have to do. So when I think about smart devices and IoT for a large utility, I kind of carry that same concept as, what could I, as a utility, get a vendor or equipment supplier to do for me to make my life simpler? And I think the two ones that I'm very excited about, I have a very supportive IT department in my organization, is one, could I get my chemical suppliers to manage what's in my tanks and use that data along with logistics, weather data, traffic data, and get out of business of having to place orders for chemicals. Although that's small in the state of Colorado, where labor is becoming hard to get your hands on, any bit helps, and that would actually result in quite a significant labor savings. The other area could be with regard to sensors is large, sophisticated equipment that a maintenance department may shy away from. Could that be censored, and could a vendor or equipment supplier use IoT and manage the data trends of multiple machines to determine when things are non-conforming and things like that? And then basically take that PM work, that guesswork, that uncertainty out of a maintenance department and into the hands of the equipment supplier and developer.
I think that ultimately what IoT is promising to bring to us is exactly what you just talked about, which is you want outcomes, right? You want to be able to have your sprinklers turn on or off automatically, whether or not you're at home, able to turn off the rain delay. Or you want your chemicals to just be managed for you. You want clean water at the end of the day. That's what you want. And what IoT enables in all of these industries is to shift the value to the final value, which is what outcome are you really looking for. And so that's something that's happened in the car industry, in our homes, as we get more and more connected with our homes and the areas there. And it's most likely going to happen in the water industry. And so that could disrupt the way things are priced, the way things are managed. But I think that along the value chain, every single point along that value chain, people will be able to benefit from this technology. You have, as an equipment supplier, the ability to better support and engineer your equipment. As a chemical supplier, you have an opportunity to make sure that everyone's always got all the chemicals that they need. And as a plant, it can increase not only the efficacy with which you run your plant, but also the ability to make sure that you're meeting your bottom line. So it's definitely, and the big change is not just that we're communicating, because we've been communicating for years, right? We've had trend lines and capabilities to see things for years. It's that now we're connected to these external services, and that's all available through the internet now. And the only other thing that I think is really big in its impact is that the devices that you guys are manufacturing enable us to do this in a much quicker and much more efficient way than we've ever been able to do, because now it's so easy to connect a sensor without having to wire the infrastructure to get there. And so I'll let you speak to that.
GlobalFoundries really creates a platform around IoT, both based on silicon and our wireless solutions. Now, when we talk about IoT and the opportunities, right? I mean, this industry could be either a leader and it could be an early adopter, or it could be a laggard industry, okay? I mean, take your pick, you could be on either side of the spectrum. Now, look at Uber. Uber's there, it's a web app for commute, and that's pretty much relying on the Internet of Things because it relies on the phone, and both the cabbie and the passenger both need to have this device, and they connect. They connect, the transaction's seamless, and it just goes through. So now, when we talk about leading adoption, right, that's kind of your leader adopter model. Now, frankly, I've been in the semicon for about 8 years, and now I'm migrating to more R&D in the fab, but fundamentally, the opportunities are in the creative thinking of the user base, okay? And I'll give you some examples that I personally had. So when we used to run like a large ultra-pure water purification facility, we used to have a lot of organic disruptions from our Muni water plant, and which typically used to come from farmers who would put fertilizers, and that would typically just percolate down the line. Now, back in about 08, 09 was when I personally put my first, it was a Motorola 5G modem connected to a small RO skid that was hooked to a Sieverts analyzer, and it was pumping that data through the 5G modem down to the Chandler SCADA system, and I had a supplier-receiver network. Now, if you think about it, that's like the most rudimentary IoT application, right? And I was able to do that just by myself. I was a production engineer back then, and I did it just cause. Why? Because there was a problem, and I had to solve it. So again, these technology platforms, they are there. They are enabling users to solve problems. People are coming up with unique application spaces. And I think today, hopefully, as we discuss through, we'll find out a little bit more about what is the problems that we have, and through dialogue, we'll figure out how IoT really fits into it, right? Because it will fit, right? Any toolkit, like Industrial Revolution, this is the digital revolution. So just like machines came in and they just revolutionized the entire productivity model that we have from back in 1900s to now, we are an order of magnitude more productive. The digital revolution is just going to take us to that higher level of productivity. So it's going to happen. Now, whether we are a laggard or a leader is something we got to discuss here. And absolutely, and that should be an interesting dialogue today.
The first two questions, I'm looking to see my friend and colleague Nancy Love, Professor Nancy Love at the University of Michigan. I don't see Nancy here, but she asked two questions. I'll kind of paraphrase them because I think they're related. But the first one is about the utilities engaging citizens, the opportunities, to use IoT to engage, the citizens, the people that we're serving, and to help them better understand the water cycle, for them to better understand, the things that go on and what the water cycle is, our role in it, and so forth. So that's the positive side of the question, the increased understanding. The second question, she uses the word transparency. So, which can have a connotation of, well, maybe we don't want the public to know everything that goes on. So, are we prepared? And what do we need to do to think about being prepared as this information gets out? Who would like to kind of jump in and comment on that first?
I guess I'll take a shot. I think when I was asked to be a part of this panel and not having a background in IT or let alone IoT, I didn't know that I would have much to offer. But when I started thinking about those things, I felt like I did have something to offer, and I think the transparency aspect of it is significant. Because I think all these systems that look to obtain efficiencies are based on sharing of information. There's no way around that. I mean, it's about using information in a format and a platform that's freely available. So when I think about the wastewater side and the use of IoT type concepts, I do think we're staring at the need for water utilities and wastewater utilities to get more explicit about whether or not there's risks, true risks, or just perceptions of risk in terms of sharing data. Because I think some of the biggest opportunities are interagency sharing of data, and that's where the real efficiencies will come. But it will require utilities to change their opinions about whether or not there's real risk or just perceived risk in terms of sharing data. And the second one is it's hard to know what exactly society wants you to do to provide them the best value if you don't reach that level of transparency. So
I got my citizenship this year, so whoa. Now, that gives me some rights, and so does the fact that I have two kids. I have a 4-year-old and a 17-month-old. Now, looking at my kids and looking at the industry in general, okay, it's the EPA methods are fairly convoluted. They take forever to run. Okay, even 8 years ago, I did a sustainability project on air pollution sensing, and a standard PN10 apparatus for counting particle sizes for 10 micron and under that are inherently, they go through your lungs and they stick in your lungs. So even something like that, a station of that one cost like $150,000 to mount. There were in Phoenix maybe about 5 stations in general, that's it. And they were pumping out data maybe once every month, right? Me and my friends, we made our own PN10 sensor, hooked it to a laptop and a GPS sensor, pumped the data onto Google Maps, and we were driving our cars around, mapping that data all over the Phoenix metropolitan, okay? One of my buddies got a master's out of it from the University of Arizona as his MS project. But the point being is, I mean, when it comes to transparency, it absolutely has to be there. I mean, we are not talking about just a need, just a wish or a like to know. This almost comes in a need to know information, right? Because wastewater discharges ultimately end up into outfalls that typically do feed water, municipalities. again, the life cycle is, a wastewater discharge ultimately through a river or a lake is ending up downstream into somebody else's drinking water source. So for me, it's absolutely it's inherently a very strong need.
We all live downstream.
Yep.
We all live downstream. David?
I think the transparency will come probably whether we like it or not, because as sensors become cheaper and cheaper, I'm going to put a water quality sensor right underneath my sink, and I'm going to be able to know, and I'm going to be able to publish and see how my city's doing, right? With or without the city's involvement, probably, right? And so to me, it seems like the transparency will come whether or not we like it. And I think there are different kind of value chains when you talk about wastewater as opposed to the drinking water, but I see that, the more we can publish like in a conscious way as to what's going to really add value for the customer, it'll be important to kind of shape and direct that message.
Yeah, because you're going to have to be careful. You're going to, if you put a lot of information out there to people that are not in our business and are not necessarily scientists or whatever, they could misconstrue it, and and then all of a sudden you got the Sierra Club or whoever involved. So the transparency is a good thing. I like what Jim said about with regulators and all that, because we do have to deal with them a lot. And eventually with people, but you have to be careful what you put out to the citizens, I think.
A direct result, though, is the air quality thing's a really good example. I don't know if you've ever been out to Utah, which is where we have an office and where I live. We have tremendous mountains and beautiful environment, but in the winter, it's a closed bowl, and the mountains trap this air, and we have a massive health crisis because of the air quality. And as a result, we've had a big government initiative for all of these air sensors all over the valley, and now I get a daily report on the air quality, and the citizens as a result are also becoming more educated as to the risks and the potential dangers. So I think eventually we'll probably have a more educated citizenry as it relates to water and wastewater treatment. That's probably a good thing.
Hey, Keith Higgs from Douglasville, Georgia. Comment, you're exactly right. We've got to be careful what data gets out there, because John Q. Public is not educated enough to decipher. What I would hate to see happen is this data sharing becomes another EPA echo site, which if you've ever gone on there and looked at your facility's permit compliance, the way they construe it, it looks like you're just killing the world. So it's going to be interesting to see how you can format this to help us all with the data, which I agree with, but at the same time, there's got to be a lot of education with the public. That's just my comment.
I think, unfortunately, what happens a lot of time in terms of pushing this transparency requirement is disaster, right? Like what happened in Flint or these other areas. Suddenly, the public's going to demand more knowledge, and so getting ahead of that message, I think, is paramount.
If I can comment myself, there's been some really interesting work there. The one that I'm particularly thinking of, some work by social scientists, but as part of the Renew It Research Center in California, looking at, why was the groundwater replenishment system able to be, to be so successfully, not only from a technical, but from a public perception, and it took so long, San Diego toilet to tap, and basically it was the credibility of Orange County Water District and Orange County Sanitary District, and the fact that it wasn't the consultants that went out and talked to the public, it was the top people in the utility. Maybe we need to go talk to people. Maybe we need to go talk to people. And 2 years ago we had a number of CEOs, and they all said that no, we can't hide anymore. The first thing is we got to go talk to people. So the question is, what organizational challenges arise in an IoT-enabled world. This could probably be the rest of the session, but so what additional skills would be required for the operations and maintenance staff of utilities? What would be the role of IT in the near future for the utilities of the future?
The one problem I can see right off the bat is we have an aging workforce. And a lot of the folks that are in the field operating don't necessarily have the technical savvy when it comes to anything with computers. Although, you know, we've slowly moved into that with some. What you need to do, though, and what we're having a hard time doing right now is bringing younger people in. The younger people are the ones that are into, you know, you see them with the smartphones all the time. You see them, you know, with their head buried in the smartphones all the time. They're used to technology and they like it, and we need to just find the ones or get the, you know, talk to some and get them passionate about water like we are, and get them interested in it. And I think those are the people that are going to be our future. I don't even know if you want to say operators anymore, because we're not going to be operating the plant like we do today.
I work with a guy, and you know, I was kind of weaned on this concern of the crisis of the aging workforce and the retirement, and he kind of said, well, to me it sounds like a total opportunity. So the interesting thing that I've experienced with regard to the younger workforce is that things like IoT opportunities in a public utility is in fact going to attract that type of talent. So I do think in this cultural shift from the risk aversion, and I think the risk aversion is understood. I think, but sometimes these are the things that we move, and these are trends that are bigger than us. And I think with regard to the generation, the younger generation, the talented people in this type of work, presenting them with these types of challenges is actually going to attract them, engage them, and help them add value to a utility, which in the end is what drives all of us. So what's very interesting is we use a lot of CoreSite now. I would have no idea how to take a process and put all the instrument trends on there and to actually, you know, benchmark trends and actually operate this process. And I've watched these younger engineers pick this thing up in 15 minutes, almost like it's intuition with regard to how to go about doing some of these things. So I definitely see the trend towards the intuition of the younger staff. Yeah.
Yeah, I think this is a time when the hierarchy of the teacher and the student gets flipped. So got a couple of University of Michigan students here. So sometimes old geezers can have teachers that are a lot younger than they are. So it's a little bit about culture in that regard. There was a question, and maybe, David, you might be the one to respond to this. So this was Scott Hawkins from HRM Environmental. You asked about municipalities overcoming resistance to connecting to the cloud.
I think Scott even referenced, you know, some of the primarily the security concerns of being connected to the cloud. And I think that there are in many cases, the benefits and the convenience of the cloud has, in a lot of ways, outweighed the risks that are associated with putting that information in the cloud. And I mean, we trust a lot of our global infrastructure to the internet and to the cloud, from banking. You know, I mean, it used to be that it was like, no, banking will never be done online, right? Because it's just too unsafe, right? But, you know, sure, the early people that are pushing this, that are building this technology, there are blunders and there are risks, absolutely. But when something happens, you know, it gets fixed and we move on. And what ultimately drives things along is the convenience and the benefits. And the one thing that the cloud can really do that your plant can't do alone is you can start to see not only trends for your plant, but trends for the industry. And sharing data between government agencies, as you mentioned, or even between different plants, and saying, okay, if we are able to look at this data collectively, can we solve bigger problems? And I think that that's the real promise of connecting to the cloud.
Adriana Felix Salgado from USCPA. Adriana asked, what organizations are, what industries and so forth are dealing with some of these issues the most successfully. So,
Yeah, I would say, I mean, for semiconductors itself, right? I mean, a semiconductor fabrication plant, so to speak, is probably one of the most complicated manufacturing that exists on this planet. It's all sometimes recognized to almost like building the NASA space shuttle over and over and over again. Our typical cycle times are around 50 to 90 days. That's about the time that it takes for us to take these raw silicon wafers and actually make like a finished product that can be packaged and put into a device like an iPhone or a Google phone. So looking at that, right? So we've got probably, I would speculate, but we have more than like 1 million sensors, even more, maybe in the 10 millions. All these sensors are constantly pumping out data. And I'll be honest, in our industry, we always say we are data-rich, information poor. We have tons and tons of applications that we deploy, and we've been deploying over the course of the years that layer into that. So for example, this is about it's a 1,000 process step, right? Our first level of coverage is around each process. Each of the 1,000 processes, they have their localized controls and they are mapping their data. Then we have a topology on top of it, which is saying, okay, if I do this, is there a cause and effect relationship with the downstream equipment? And then there's another side which is saying, well, what is the upstream effect? So then you get like a 1 degree or one process to the left and the right of this process. So you connect 3 processes, and that's a topology understanding by itself, direct consequence. If I grind something, does it affect the next operation of cutting it or cleaning it, right? Then you can connect more on top of it. So we've been in the journey of trying to deploy these quote-unquote applications. For the semiconductor fabrication plant itself, the devices and the sensors are deployed. The data is there. Now it's a matter of understanding the data. So we are not in any sense of we are not like an ideal state or anything. We are in a practical state, for sure. Right now, on the leading edge nodes, we quantize and we are able to get the yields and the product out. But as we get more and more sophisticated into this space and as we start connecting the data sets, we will learn. And a large part of these organizations are the kids that are coming out of school now, it doesn't even matter how much schooling they have. Even if they come out of 5th grade, they're still really good at data and data analysis. It's becoming like this, it's more intuitively like almost like an alphabet type of a thing, This is so intuitive that the generation picks it up faster than some concepts like engineering design of a mixer and Reynolds number and turbulence. They don't understand that, but they can see cause and effect relationships and they get it. So in our industry, we've been doing good. We're not there yet. We are slowly making, even in our own industry, making quite a few inroads, trying to understand our data and drive solutions out from it.
So let me ask the audience here, how many of you went to school to learn how to use this? Did anybody go to school? Did you take a class? Did someone formally teach you how to use this? No. We you get one, you talk to people, and you figure it out and so forth. I think that's I think we actually know how to do it. That would be that's the point I'm trying to make. You start where you can and you move forward and, you learn and if something works, you keep doing it. If it doesn't work, you do something different. So I would suggest that we just think about what we already know about how to do this as one way to get going. So the question is really about the, we got all this data and so forth. Where does something like artificial intelligence and so forth start to, to fit into this? That I think was the question.
So Google's neural network platform, they recently had this success where there was this ancient Chinese board game called Go, and it was anticipated. It has many more kind of derivations of moves than there are atoms in the universe. It has just trillions and trillions of possible moves. And so this was kind of considered to be the grand challenge of AI and machine learning and neural networks. And they, last year in the 2016 developer conference, announced that they had won or beat the world champion in Go. And this wasn't expected to be, happening for another 10 years or so, And essentially, machine learning and neural networks have been around and hyped for a very long time, but it's becoming very real. And the big conglomerates, the people who are paying attention, are investing big money into this idea that when we have terabytes and terabytes of data coming from a single plant or multiple plants, it's near impossible for a human to take all of these different dimensions and variables from weather, from these millions of sensors that you're talking about. We just don't have the capacity, right? But when you plug that into this algorithm or this neural network, that can start to detect patterns and causalities more than we'll ever be able to. And so that's kind of the promise. And this, I believe this will be the prominent IP of the industry going forward. And you'll probably see software people creating that IP and creating that space in the water industry very rapidly, I'd imagine.
I was at a technology forum in water. It's the Paul O'Callahan's Blue Tech. The sensor vendors that were getting traction were ones that not just had a sensor, but had it tied into an AI system. People don't want numbers. They want something to tell them what they need to do, right?
I got a question about really the internet, the IoT, which is along the lines of what Jim was talking about in regards to getting chemicals without ordering, thinking more that you might have a technology that will feed information and get to know with the vendor the maintenance schedule, why it's not performing. How is that going to affect the social aspect of this, and maybe the operators being kind of afraid to lose their jobs and the interaction? Because when you do that, that's the other side of things, that people are not going to be more, you're going to see resistance. When I was doing PhD, I was trying to do automation at the time, and I found that a lot of the operators really don't want to interact with this machine, because if it's got automated, then they lose their jobs. So how do you think that's going to affect going into the future, the IoT?
I think natural attrition should pretty much get you you will get the replenishment of the workforce with the youth and energy that you need to adapt to this environment. That's one way to look at it. I think coming back to the gentleman behind who said about is this like just a separate thing? And I think if you ever have to think about adoption of anything into your departments, right? You typically, no plant manager or a division head is going to just in-source something from day one. What do you typically do, right? You go out to a consultant, you go outsource it, you test trial it, right? You may be spending, $1.20 to the dollar to get that service, but you kind of pay the price for it. You say, you know what, I don't know it, I don't trust it, I want to do it at a small scale, I want to do it only in one plant, I don't want to deploy it to all plants, I don't want to spend the training dollars to skill up everybody without even knowing whether this has any value or not, right? So typical adoption, the way I see it's going to happen is you're going to go out there, you're going to get some services, and folks will give you these services. Like the gentleman mentioned, that there might be an AI service that might come online that allows you to do, let's say, very smart life cycle asset management, right? And it gets deployed on top of your SAP or Maximo-based systems, whatever those might be, right? We could overlay it on top of your SAP systems. Those things could be deployed for a yearly fee, right? You see whether there's a benefit in there. If there's a benefit in there, then it gets into the next phase. And maybe over a couple of decades, maybe after you retire, if that's what you really want, right? Sometimes the question for everybody is like, I just want it to happen after I retire, right? I don't want this technology stuff to come in before I retire. So
I see this happening more quickly at the bigger plants because they can afford it. All right, when you've got a plant that's 10,000 gallons a day, I mean, we have some that are like that. Our biggest plant that we run is 3.5 million gallons a day. That's a big plant for us. And these little communities that we work with, the money, it can't be expensive. If you want to have it adopted, I mean, it needs to be cost effective for the little guys.
The trend I've seen, because I remember the same conversations not too long ago, with just with process control algorithms and inline sensors, and really just sitting here thinking about it. I remember 7 years ago when I first started working for the district, moving beyond probes for just monitoring. So that was where we were 7 years ago. Is let's put some probes in there and they'll monitor. 7 years later, and the pushback then was, well, they're wet chemistry analyzers, they're sophisticated, there's these, but sitting here over 7 years, I've watched these sensors become massively simpler, massively more available, and massively more integrated into our control system at the utility. So when I look at our distributed control system, and I look at the screens, and I look at what the operators are doing, it's significantly more than 7 years ago, and it's never resulted in anybody losing their job. It just, all right, now you have more time now you have less stress, and now you have more time to do something else of higher value for the organization, and that's the evolution that I'm seeing. So.
Yeah, there was a study I was listening to that talked about that idea, and it's certainly the way we do things, the way we operate, the way those processes evolve doesn't necessarily translate to a loss of jobs. The jobs change, absolutely, and even over time as the process gets more and more sophisticated, the adoption comes and the job descriptions change, but it doesn't necessarily mean that we're going to be in our sim environment and world, lying in bed all day waiting for, the virtual reality to happen, yeah.
Yeah, it was like the Jetsons, right? By this time, we were supposed to only have to work about 3 hours a day, and
Besides the human aspect, there's also the regulatory aspect. Currently in the States, you have to have a certain amount of days, hours, with a certain license to operate a certain size facility. So I think, how would you go ahead and go to regulatory agencies and get something like this passed?
I've worked with a bunch of municipalities over the last 10 years, from Arizona to Oregon to New York, Israel, Ireland, and all of these places. And I've never really found regulatory agencies to be, if you have a solid plan, and if you document it, and you write it out, and you propose it, it tends to, you just need to do the upfront work of planning all of this out. We haven't had very many regulatory agencies that were just hostile to us, especially from the semiconductor side. As long as we went to them with a very clear plan of actions, because I was telling these gentlemen here that in a typical semiconductor factory, we use more than 15 to 16,000 unique chemistries, unique chemicals by CAS code. So, we do tend to have quite a few dialogues with regulatory bodies.
I need you to come to Maryland then. We have our own challenges. One of the things that I'm very involved with and very passionate about in my job is water reuse. And I can't even get the regulators in Maryland, we've got some basic things, but like, Glenn was talking about toilet to tap in Orange County. They've done a lot. Texas has done a lot. Arizona's done a lot. Maryland, not much. Irrigation mostly, or cooling for computer things like that, cooling water, applications. That's it. So for regulatory, that perspective, I think is going to be, at least where I come from, it's going to be difficult. I mean, I think if we develop a plan, I think if they can see it maybe in neighboring states or whatever, we'll get them convinced. But right now, it's going to be tough.
It's going to help eliminate those roadblocks. So when you come up with the qualification plans, right, and when you say, I'm going to do this metrology and I'm going to measure it at this frequency and I'm going to publish that data so quickly to you, that's what IoT essentially does, right? It just enables you to get the data done quick, get it turned around, get it compiled, get it analyzed, look at the trends, look at the outliers, do the AI if you need to, whatever it is, it's just going to make it that much more snazzier and easier to make your point and move on, right? Which is the typical roadblock today. You're not able to make your point with these guys.
Yeah.
When you deal with people, things take time. So if something's going to take time, we better start today. That's one of the things we tend to, when we want it is when we start working on it. But you got to start early and start working on things if it's going to take time. So
we're here tonight because of an equipment supplier, a big company that makes equipment for wastewater treatment plants, and I would like to throw the challenge back to them. My car tells me when I need to change the oil. My insurance company keeps track of where I drive and how I drive. I would like to be able to purchase a piece of equipment and have the supplier monitor, and have the supplier tell me when it's time to do things, and have the supplier tell me, hey, we've been looking at your data and you're not really operating this equipment properly, or why are you having to do this? I would like to see a shift in that direction.
Come on by the booth. We'll give you a
no,
full-
I was gonna. There is one person here who is in those shoes. So, David, why don't you go ahead and
yeah. I
talk
mean,
for a minute.
this is kind of the primary goal of what we're trying to accomplish at Ovivo. We realized that we needed to do a good job of improving the user experience. And we are looking to those other industries that are doing that and having success in that, and we want to bring that to our clients, so the end user, and create those efficiencies and simplify the game for them. And this is a big initiative that we're pushing. We want to be a big provider in this space as it relates to providing software. And it's not, as they were talking about this, it's when you deal with people, things take time and change. And this is a big culture shift for us, even as an organization, to start to shift our minds and our development away from just being an equipment supplier and then hoping things go well for you, and then we'll see you in 20, 30 years. We're shifting our mindset to adding a lot more value to that piece of the chain, and then even looking at the full value chain as well. So yeah, we'd love for you to come by and show you what we're doing.
And I can attest to what they're doing because we do have one of their plants at one of our facilities, and we're talking to them once a week. They're looking at how our plant's doing, the data. Have you done a clean in place recently? Things look good. No, maybe you need to do another one. Maybe you need to soak it this time a little bit longer, use different chemicals. I mean, it's pretty cool. It's pretty cool. They've been very, very responsive.
That is a very good question, though, because I will be very honest. I have not yet seen a standardized specification around IoT deployment on equipment sets and remote operations and management, right? It's probably a gap. I don't know. I don't think you guys operate with any standard specs either.
Malik here?
Yeah.
No, it's certainly something that is in the works. I mean, it's a broad spectrum of things that we're working on, but But the water piece in the semiconductor manufacturing is one of the more complicated pieces of the whole manufacturing chain, right? And so it's certainly somewhere where we're looking to add more value and bring those types of standards and not only provide the equipment and the process design, but like helping you to extract that value out of that data. So.
But I think the concern
Well,
is
in our industry, it's the owner and the owner's engineer that writes the specification.
yes, that's
It's
why-
the owner and the owner's engineer that writes the specification. Maybe this is something this group ought to be talking to WF and so forth about,
Yes.
working collaboratively to develop something like
yes.
that.
Make an end user specification.
This
that
is
makes
not,
sense.
this is us.
Yes.
Let's figure out how, if we need to do it, let's figure out how to do it.
Which leads to my question. It's wonderful that you're talking about every pump, every controller, everything that needs maintenance, having a chip, and then sending information connected to the internet. And now, many municipalities are using smart meters, so they are in a way connected. And now, a lot of manholes are coming with the Internet of Things, so every manhole will have that. So what that is going to lead to is explosion, the exponential growth in the number of devices all around. They're all connected, right? Now, does that lead to some mischief making also? Now, even with limited connectivity now, there's a lot of mischief making. The Equifax hack, the Yahoo hack, and then, there was a federal employee database, there was a hack. All that. Now, isn't that going to be an increase in that hacking also? Some smart 9-year-old kid in a computer club in an elementary school could say, hey, look what I found. Let me order 500 trucks of chlorine here for Jim McQuarrie. So, automate. So how do we prevent that? How do we make sure that the explosive growth doesn't lead to the explosive growth in the hacking and mischief making?
Yeah, great question. I don't know, Jim, you were mentioned.
No, I was going to say is,
Oh, you nicely punted
well,
it over, buddy.
I think it comes down to optimism. So the so there's
It's going to be fine.
no, so there's a I remember seeing a photo years ago, and you could probably find it on the internet. It's a picture of like 7th Avenue in New York City around the turn of the century after the telephone came out. And sure enough, there were thousands of phone lines running through the sky across that city, like just darkening the sky. You couldn't even see the sun through all these wires. But in time, society catches up with the innovation, and things calm down, and we're better off for it. So I just think that's just kind of a recognition. I would never take those concerns as a reason to not. I would certainly. That's one of the comments about transparency is we really have to bifurcate perception from reality with regard to our concerns about transparency and risk.
I feel sometimes that I have those old TVs. Do you remember that you have to change the channel by moving the knob? And the signal was one wire coming off. I used to have those with my grandparents. How you can have that infrastructure, that old infrastructure, with these new connectivities, it just doesn't match. So even if the manufacturers innovate and present us all these options, where we are getting the money to implement it?
Fundamentally, from an economics perspective, I think there's a misconception around IoT that it's somehow a $700 device or a $2,000 computer that folks are trying to sell. So even the basic computing functionality in most phones comes at about $20 per phone. Most of the money actually goes into the Gorilla Glass, believe it or not. So just the deployment vehicles around IoT are about, like, they range in about $2 per device. Just the enablement piece, okay, which is the silicon or the wireless or whatever all the sensor deployment is, that's within like a $2 footprint, right? Now, how you package it and build it up, right? So if you think about it, these are not going to be extremely expensive. You're not going to be changing out a $17,000 or a $35,000 analyzer to make it IoT compatible. To make an instrumentation or metrology compatible with IoT is probably going to be a $5 to $15 doohickey that you attach. Just like your Google Chromecast, right? Google Chromecast takes a dumb TV and makes it into a smart TV, right? For I think $35. That's it. Right? But the TV could be a $500 old antenna style, knob style TV, right? But you plug one stick in, which is the $35 stick, which really only costs $7 to manufacture, voila, you're IoT enabled, right? So it's on the pragmatic side. I think you've got to be cautious, but also be real that these are going to be not super expensive, multi-million-dollar investments that need to be made. These are like $100,000 type add-ons that you just need to do to get you going.
Jim, maybe I can, question you were going to address was how do we do this? What new opportunities do you see? From Barbara Wilson about the skills, but then Carl Fisher from Baxter and Woodman asked for a specific example.
It's pretty interesting. So the place where I'm trying to think of where to start with this. So we have this the new Department of Strategy and Innovation, and it'll be 1 year old by the end of this year, and when the manager decided to create this department, a vast majority of the change agents within our organization came out of the IT department. So which is very, very interesting. Almost like sitting there waiting for the organization to wake up. So now there's an inundation in terms of opportunities to really, really be smart with devices. And listening to you talk, company Arable Labs develops these, it looks like a little disc, and it has about half a dozen different sensors, very inexpensive. And you connect remotely, so you don't have to worry about wiring or anything, but we have our biosolids program is rather slick. So we take our biosolids from our facility. There's one stoplight between Denver, Colorado, and Kansas City. So that really helps in the efficiencies of this.
Found a use for Kansas, huh?
Yeah. So our biosolids program, we move biosolids off of our facility through that one stoplight, and then there's nothing but hundreds of miles of corn, wheat, or irrigated corn, and so both those crops like nitrogen, and we have 52,000 acres of land. And when we take those biosolids, we get rid of them. That's our core business. But our R&R department, who manages this, is now focusing on wheat yields. Like how do we then turn around and maximize our profit from our wheat yields? And so we're sitting here as an organization, awake and ready. But this company offers an IoT device that we could purchase very, very cheap and put it in all the different microclimates of our 52,000 acres of land and really generate meaningful spatial data in terms of what the optimum productivity locations are for our 52,000 acre project. So it's kind of an interesting concept that I think fits well with this panel discussion.
Yeah, terrific.
How cheap?
Oh, I think
No, I mean, just out of curiosity.
$650.
See, and I have
I
trouble.
could-
I have
I
trouble
could-
adding that much budget
So I'll
to an
just give you a
operating
two-
budget for some of our small facilities. $650 to a town of a few thousand people
Yeah.
is tough.
Yeah, but and the goal here is to maybe generate several $100,000 more a year from your wheat yield. So the business case is there.
David, what do you think an ideal IoT world looks like? What is the formula for success for the utilities of the future, for the evolution of maintenance? And Henry Hervold says, what does your panel think about the effect of robotics with regard to utilities of the future? So, you know, if treatment plant operators are worried about sensors, just think when they got robots wandering around doing things and so forth.
Well, our robot overlords will not tolerate mistakes, so you can count on that. But I think as it relates to what does an ideal look like, an ideal IoT world look like, it's a process to get there. There's the maintenance piece of it, though, and I think there's going to be human involvement for a long time, right? And we have some time to figure out the social implications of things becoming more and more automated. But I mean, we're even dealing with some of that now after the Industrial Revolution still. So, but people are going to be around for a while. But as we go, and
we hope
30. We all have like 30 years left at least. At least 30.
That's the objective, right?
But in the evolution of maintenance, they talk about how you start in a reactive mode. So essentially, something breaks and you go and fix it. And there are a number of plants that are in that mode, right? Go fix what broke. Then it goes into the next stage, which is preventative. And this is, I'm on a regular schedule. I'm going to get my regular, 6-month oil check, or oil change. And then it goes from there, which, a lot of plants are doing. It goes to predictive, which is the promise of AI and neural networks. We can say, wow, look at all of this data, and we knew when that failed, so we're now going to be able to predict, or the machine will tell me, hey, before this pump goes down, you better get over there and fix it. And then the final step of what the IoT Mount Everest is that we can start to get prescriptive maintenance, right? So now the machine's telling us, not only is this potentially going to fail, but this is what you should do about it. And we're going to have human validation for years to come, right? I mean, but it's going to be easier, and it's going to be a better user experience. It's going to be simpler than it's been in the past. And so I think that the concern and fear around what the IoT world will bring, I don't think that's the ideal. I think that we're integrated. I think it's augmented a human experience. And so that's how I see it.
So with kind of the theory of pumps coming down, and are you going to record it? Is the device going to have something that's going to tell you your horsepower, your RPMs, your amps, and kind of judge it off of that? So this piece of equipment went down because of the amps going down or a clog or something, and then it all relays back to the whole system?
Absolutely. I mean, that would be somewhere like that. I'll be honest. In the semiconductor industry, we actually do use those fault detection algorithms already. It's called FDC, which is fault detection and control. It's essentially a layer of network topology that takes like an abatement system or pumps, typically pumps, lots of moving parts. Like wherever you have abrasion and friction, right, you kind of have to monitor it. And then we would typically, in a factory like ours, would probably have like more than 1,800 vacuum pumps, right? You're not going to have, at some point it actually gets boring for these operators to mundanely just roam around with a device and just take vibration sensors over and over, and that's your job. I mean, it kind of like, it just becomes really boring. So by deploying these sensors across the board and then mapping them into a fault detection and control platform, is how we then track and monitor all these pumps, make sure that the staff of 5 or 6 that we really have, they're not chasing false alarms, but that they are actually going. And our fabs are typically big too. I mean, these are like 400,000 square foot clean rooms. It's a hike, right? And even your plants are big. You don't want to send guys out chasing false alarms. You want to send them with the kit, with the parts, all assembled, already known, right? You don't want to go there to troubleshoot. In ideal case, you want to go there to fix, right? So you want to get the troubleshoot, the causation, all done by the fault detection control systems. Let the guys actually know what needs to be fixed so that they can be properly kitted with the tools and the procedures that they need, and then you deploy the guys out into the field. That way, you get their productivity up, their job satisfaction goes up, because they're not just chasing like, what am I doing? I'm going to go hook this thing on another pump all day long. No, they're doing some value work for the company, and they come back, you feel good, they feel good, and it's like a win-win for everybody.
I'm sitting here thinking, and a lot of what you're talking about sounds really good, but as far as relevant, one of the biggest things that we're faced with is optimization. And a lot of our, we're optimizing blowers. That's one of the biggest energy users, and nutrient processes and so forth. And a lot of the testing that we do is a day or 5 days later than what we need. So can you give an example of how something like this might be real-time data?
In my experience, we're driving down to some of the fundamental parameters to measure. And I think, right now we think, well, dissolved oxygen, ammonia, phosphate, those are all the right parameters. But probably not. We probably even need to go down to like enzyme activities in the processes and things like that. So in a lot of ways, the only thing that's holding us back as an industry, I think, is just sensors. So if you think about a biological process, we're still, even if you look at aeration control, so we went from dissolved oxygen control to model-based ammonia control. That's a massive improvement. But just the imagination of, well, what if we start looking at enzymes and RNA and things like that in the process to where we can really, really understand the opportunities in terms of optimization. So I think sensor development is probably the only thing that's going to be keeping us back. Yeah.
I think the key to this, though, is like the uncovery of what the variables are, right? That's right. As we start with our parametric modeling of how we understand the universe, and this is what we program into the pumps and the machines and the automation, and this is what's been going on for years and years and decades even, right, in our automation. But when you move to a stochastic model where everything you decide is based off of this random data that you're getting from as many variables as you can capture, now it's different than what you thought it was. And as soon as we find that out, we're like, oh, well, I need enzymes. I need more information in order to properly control this, because when you take a spring equals Kx, it's a lot more complex than that in the real world. There's a lot more going on. The humidity, everything, the materials. It gets a lot more complex than our parametric modeling, and that's why the uncovery of the variables is why you have to start. It's because there's a lot that we don't know. And capturing that data first and then trying to build off of that data is the best way to go forward.
Let me share two examples, both more on the water distribution side. But right after 9/11, everybody got worried about, we've got to deploy in our water distribution systems these systems that will detect any kind of intervention. People started to develop all kinds of sensors for all these weird and wacky things that could be there. What folks learned is that if we measure pH, chlorine residual, and turbidity, it tells us an awful lot. And it wasn't that was so insightful. It is that those simple indicators, to your point, David, when we understand what's really happening, sometimes simple indicators, but with a complex understanding, does the trick. Takadu is a company that's been operating very successfully in the water distribution area in terms of leak detection and non-revenue water and so forth. What they do is they use data mining. They don't deploy anything new. It's basically looking for any signal they can and putting that into data mining and just looking for what's different. I think it's a combination. I mean, the sensors are important, but the better we understand things, so many times we try to solve problems by dealing with the symptoms, but you got to get to the real cause. Oftentimes when you get to the real cause, the indicator, it's counterintuitive, but it's actually pretty simple when you finally understand it. So I'll read the question here, but what issues arise in the IoT world? how you deal with, part of it is about compatibility, a question about compatibility, a couple questions about compatibility and so forth of these systems.
I think we talked about opportunities, and I think the request is to close with some outstanding issues or concerns around IoT. Right? I think organizationally, I think definitely there's a challenge. Now, working in semiconductors, I know our primary workload had transitioned from operations and maintenance to metrology maintenance. So we have about 40% of our workload at the water and wastewater facilities is predominantly metrology oriented. And so it's just, it's like David said, it's going to be a diversification over time that has to happen, and you just change. It's not a numbers thing, it's the description of the job rec that changes over time. Typically what we have noticed is complexity just keeps on going up. You just tend to need more and more people over time. In terms of the question that Dr. Dygert had about compatibility of devices, I think I answered your question, the lady up in the third row. IoT as a platform has a cost that is significantly smaller than any of the devices that you currently have in the consumer marketplace. So when we talk about industrial automation, I think somebody mentioned a $650 device. Like, I think there's some inherent cost buried in the cost to innovate, the R&D cost. Because I do just on my spare time, I will look at teardowns of a bunch of stuff, and typical bill of materials wise, cost is very, very low. Even the iPhone is still only a $200 device. Yes, it goes for a much larger thing because there's so much R&D that goes into it. But from a bill of materials aspect, all these technologies, right? Yes, there's requirements for compatibility and maintain upgradability concepts, but over time, these are all commodity technologies. These are like detergent type stuff. You're just gonna go into a cycle of usage, and every 10 years, you'll just cycle through your electronics just like you cycle through stuff.
In terms of the challenges, I think certainly it's clear that we have big organizational challenges that will come. But I think one of the bigger ones is connecting your plant in the first place, right? Getting things to finding a partner or a group of IoT device that helps you connect your plant. This is the first hurdle. This is the first kind of barrier of entry to your plant. But it's not as daunting as it seems, I think, and that's the message that I think is there. And then in terms of like the fear aspect, the issues, I think your optimism comment really hits home for me. It's like we have to essentially say this is really going to benefit us as a society as we go towards this common goal of treating our water better, of preserving this precious resource better. This is a very good approach, and it's a much more accessible approach than it's ever been. And it's not just going to be limited to the big plants that have the resources and the personnel. It's going to be available for these small cities. And that's what we see as really exciting, is that this opens up not only a whole new slew of business opportunities for everyone along that value chain, it's going to really impact how water gets treated in our industry, and that's one of the big primary motivators for us.
My closing comment would be something that my IT officer drills in my head, and that is that we already have huge amounts of data, but such small quantities are usable. And so I think I think a lot of utilities are in this space where knowing what we know now, we never would have built IT-wise what we are currently sitting on. So I think to get ready, I think it's important for utilities to start getting ready and to have an IT architecture that supports these concepts, because I think your comment with regard to SAP and asset management and actually doing real things with the data, it needs that platform for it to really take hold.
And my closing comment is going to be, I agree it's a benefit. I think, that at some point, even the smaller utilities, I can see it being used more. but we're going to wait till the gyms of the world get it online and show us that it works, and the cost starts coming down probably before it starts filtering into the smaller communities.
Yeah, everybody adopts at a different rate as you need. So, nobody has to do any of this other than as it moves forward, if you aren't paying attention, you get further behind. One of the things I've learned about the change process is that new things grow exponentially. I've come to realize that as human beings, we think everything is linear, but new things grow exponentially. Now, every one of you knows this mathematics, that when you plot that on an exponential growth process on linear paper, it does this. So we look at, when it's in this phase, we put the straight line through, and we're surprised when how did that happen? Well, it happened because it's new. It's a natural thing that so if nothing else, from my perspective, if nothing else you take away from this is to, keep an open mind, look, and realize that we're going to see those inflection points in a number of things, and don't be surprised by them because it's natural. That would be my comment. So I think they've done a great job, haven't they? Let's give them a great hand. And you guys too. And thanks to Ovivo for organizing this, and I think Elena is now going to give us our instructions for the next phase.
I don't think it's instructions. So I have to say, since I've been to all 20 of them, this was probably the most difficult one from a topic point of view. But then I kind of thought about it that the first one, everybody thought we were crazy to talk about aerobic digestion with solids at 5 and 6%. And now it's like normal. Nobody even questions that. But I still remember the topic was so provocative at the time. And now this seems to be provocative at this time. But I think the message is, if you guys don't jump with this, you're going to be left behind. And if you want to do something to embrace this, it's an opportunity to bring in young people that we're having a very hard time to get them in our industry, to get them in our industry now. Find something exciting for them. That was one of the things I asked Jim. I said, I met some of the most brilliant engineers working for you. How did you get them to work for you? He said, I found something very exciting for them. I'm doing things that they feel that they are improving the world. And this is something interesting that I got out of working with these guys in the last 3-4 months. They said, we don't do this for EPA anymore. We don't do it to meet a permit. We do it because we want to make a better world. And I guarantee you, my 20-year-old daughter, that's what she thinks about every day. She doesn't worry about regulations. She wants to make a difference for the world. So you guys are going to be hiring these 20, 30, 40-year-old people. You give them something of value, they will figure out how to make you guys money and make these guys meet their permit. And that's my comment. Thank you guys. And I hope this was provocative enough.